So in this video, we're going to be talking about conic sections, which is I think it's an interesting name because the conic sections refers to a group of geometric figures or curves, if you will, in the coordinate plane that are found by slicing through cones. And so you can see here before you picture. You can see so we start with these two cones that are stacked on top of each other with their points, pointing towards each other. And depending on how you slice it, the cross section produces a different shape. And you can see in figure A, because we're slicing at an angle parallel to the side of the cone, it produces a parabola. In this case, I'm slicing at an angle, but it's not parallel to the sides of the cone. It's going to go through both, but it's not flat. That's going to produce an ellipse, which is kind of an elongated circle. And then this last one, where I'm slicing straight up and down, that produces what is called a hyperbola, where it's kind of like two parabolas that are facing away from each other, and they can go up and down, or they can go right and left. So. And then there's a fourth conic section, which is a circle. They don't have to draw a picture of it, but you could picture if I sliced right through, straight across this, you could see that it produced, just a regular circle. Not as good a drawing as this, but this is why I had well, anyway, you can hopefully see that. So those are the four conic sections. You have a parabola, ellipse, hyperbola, and circle. And this section, we're going to be talking about how to sketch them and write the equations for them and connect an equation to a graph. Now, two of those you should already know. You should already know about the parabola and the circle. So we're going to start with those in this first video. Then we'll talk about the ellipse and the hyperbola in the second video. Now, the parabola, when you think of parabola, you probably think of y equals ax squared plus bx plus c, or you think of y equals a times x minus h squared plus k. This would be standard form, and this would be vertex form. And I think most of you could graph it pretty easily from the vertex form, and even if it's in standard form, you can use negative b over 2a to find the x coordinate of the vertex, and et cetera, et cetera. So that's kind of what you know about parabolas already. Today, we're going to look more at how a parabola is formed. So the points on a parabola are the points that are equidistant from a point and a line. And you can see in this drawing here, it's kind of showing you that the vertex is h comma k. That's where this h and this k come from, right? Notice that I was just going to say the same thing I just said, that the location of the parabola, the vertex of the parabola, is easy to find just by looking at the vertex form of the equation. The thing that's not so easy to find is the a. Now, in pre-cal, we talked about the a being the stretch factor. But another way to look at a is, we'll scroll up here for a minute. And when you see parabola, here's the parabola. This is kind of the key feature here, that a is always going to equal to 1 over 4p. Now, what is p? P is the distance between the vertex and the focus point, or the distance between the vertex and the line, which is the directrix. Now, you can see the line right here. And you can see the point right there. That's that yellow. Oh, I should just use a different color so it's not confusing. We'll use green for that. So the little green highlighted point is called the focus point, and the yellow highlighted line is called the directrix. And why these are important, because this is how the shape of a parabola is formed. A parabola is the set of points that are equidistant from the focus and the directrix. So if you were to measure the distance, that distance and that distance, they're going to be the same. Likewise, if you were to draw a line out to this point right here and draw a line down to that point right there, those would also be the same. Now, it doesn't necessarily look the same in this case, but that's bad drawing. But That's the nature. And no matter where you pick the point, if you pick this point up here, then once again, that distance and that distance would be the same. Okay, so that's the idea of a parabola. And so when you're talking about parabolas, you can use this same stuff you already know to find the h and k, because if you know where the vertex is, then you can find the h and the k. And in this case, to find the a, all we need to know is where the directrix is or the focus point. So for example, if we know let's say, well, let's do an example. We'll hop over here real quick. And so let's say that we have, we know that the vertex of the parabola is located at 1, 2, and we know the focus point is located at 1, 3. Okay. Oh, now one other thing before we do this example, just so we cover all of this. Another thing that's unique about parabolas is you can see, normally we think of a parabola as facing up or facing down, but in this section on conic sections, you could actually, a parabola could face right and left too. And you can see up here, notice that that's in terms of, that would be facing right and left. That one would be facing up and down. This is the one that we're used to, right? Y equals something involving x squared, right? That would be an up or down parabola, depending on whether a is positive or negative. This would be a right or left parabola, again, depending on whether a is positive or negative. Okay, so let's hop back to here. And so we want to write the equation for this parabola. And really, that's all the information we need to know. Now, we could graph it, just so we can kind of visualize what's going on here. So if we go over to the vertex of over 1 up 2, put a dot. Focus point is over 1 up 3, put a dot. So maybe you can visualize the parabola. You know, I don't know exactly what it looks like, but looking something like that. We could also draw in the directrix, because we know the focus point, the distance from the vertex to the focus point is equal to the distance from the vertex to the directrix. So that means there should be, again, this is not a part of the graph. It's just what helps us draw the graph, right? So this focus point is not a part of the graph. The graph is just the parabola still. We're not changing that. I mean, it's still just a parabola. But these are features that help us form the graph, the parabola, and we're just noting where they are. Okay? So now to write the equation, we know that this has got to be y equals, because it's facing up, right? And this is going to be x minus 1, because the vertex has an x coordinate of 1, squared, plus 2, again, because the y coordinate of the vertex is 2. And if you remember transformations, you can think moving to the right 1 and up 2, right? From 0, it's moving right 1, up 2. So that's where that's going. Now, to get the a, because that's all we're missing now, is we know that if this is a, we know that a is equal to 1 over, what was it? I think it was 4p, wasn't it? Yep, 4p. Okay, 1 over 4p. And what is p? Well, in this case, p is 1. We can see the distance right there. The distance from the vertex to the focus point is 1. So this a would be 1/4. So we erase that and put 1/4, and that would be the equation of the parabola. Now notice I put a positive 1/4. There's nothing about, p is a distance, so it's not going to give me a direction. So we know that the parabola is open up because the focus is above, the focus point is above the vertex. So the parabola is always going to kind of wrap its arms around the focus point. So we knew that the parabola is facing up. That's how we knew that this was 1/4 was positive. Because the p, like I said, the p is just a distance. So it's not going to tell us whether it's positive or negative. It's just going to give us a distance. So we can find the number, the value, by using p, but we have to know which way the parabola is facing in order to determine whether it's positive or negative. Okay, so there's one example. Let me give you another example. Let's say that we're just looking at a parabola like this. And we have a point right here and let's say the directrix is right here. No, that's the same as last time. Let's do it like here. That'll be really funky. Okay. So there's the directrix, there's the vertex. So the parabola is looking something like this, maybe, I don't know. So we know that in this case, P is 3, right? We know the vertex point is 2, 1. And so we're going to go ahead and write now, because the vertex is to the left of the because the directrix is to the left of the vertex point, we know that the parabola is facing away from the directrix. So this is going to be it's facing to the right. So this is going to be x equals something involving y squared. That's what makes it face right and left. And since it's facing to the positive direction of the x-axis, this would be we know that a is going to be positive. And let's see, so if we put in here, this would be y minus 1 squared plus 2 on the outside, because again, we put the 1 with the y and the 2 with the x, right? And then my a is going to be, in this case, a is going to be 1 over 4p, which would be 1 over 12, right? Because the p is 3. So I'm going to have 1/12 in here, and again, it'll be positive 1/12 because I'm facing to the right. If it was facing to the left, it would be negative. Okay, so there's a couple examples of parabolas. I also want to talk about circles in this video, and you can look on the information of the Conic Section fact sheet or whatever, which, by the way, you can use that Conic Section fact sheet. You can use that on any test or quiz or final or midterm that we have in here. So that's for you to use. So the circle, I'm guessing that a lot of you have seen this before, but some of you might have slipped through the cracks and never got exposed to this in your mathematical history. But that is the formula for a circle, and where h and k is the center is the coordinates of the vertex. H and k is the coordinates for the center of the circle, and r is the radius of the circle. So if I'm looking at an equation that's x minus 3 squared plus y squared equals 16, that tells me that if I wanted to graph that, it'd be really easy. I would just go, let's see, 1, 2, 3, and then notice, 1, 2, 3, and notice that there's no y. Essentially, you could think of this as y minus 0 squared. So the coordinates of the center would be 3, 0. So the center's right there. And since this is r squared, we know the radius of the circle is 4. So I'm going to go over 1, 2, 3, 4, put a dot, up 1, 2, 3, 4, put a dot, over 1, 2, 3, 4, put a dot, down 1, 2, 3, 4, put a dot, and then just draw a circle the best I can, which is not beautiful. So that's a circle. Now, sometimes what we'll do, especially for right now, it wouldn't be startling for you to say that I could have wrote this guy as x minus 3 squared over 16 plus y squared over 16 is equal to 1, right? Just by dividing both sides by 16, you'd get that. And so then you could also, so in other words, you could also think of this in general as the circle like this. And again, this is nothing startling or different. It's just just moving a few things around. So you could think of the equation of a circle like this, or you could think of it like this. And think of it like this is helpful because it relates it to the equation of the ellipse and the hyperbola, which we'll talk about in the next video. Didn't want to spend a lot of time with circles because I think they're pretty easy once you get the idea of what the equation looks like. All right.